Myself, Sri Surya Teja Bapana. Thank you so much for giving me this opportunity and opportunity to present this paper and my idea in front of everyone. And myself, Sri Surya, I'm from Troy University. I've graduated in 2018, and I've been working on the paper and advancing this idea of image communication through new approaches. Right now, I'm working as a senior data scientist in an AI startup, California-based company as a product owner too. So this is very high level about me. Today, I am going to present a a normal approach. A regular idea with a new approach, which is called how securely we can send a message from point A to point B with different encryption techniques and different methodologies. So here my paper was titled as Secured Image Communication with Dual Encryption and Reversible Watermarking. So today I'm going to present this in a format of the following contents, like I'm going to explain the abstract introduction. It goes with the procedure like this. Coming to my abstract, like this paper is mainly about a secured image communication. So here I have implemented the data encryption, decryption with with a encryption algorithm, and also a threshold-based compounding and in a reversible watermarking technique. And also during the encryption, I have implemented a new approach called genetic operators, where the genetic operators, the word and the concept has came from the genetic information and the genetic concept. So the crossover and mutation. I have used these both to encrypt my messages, which I'm trying to send from point A to point B. So the motivation that I've got from this to develop this is like there are separate individual ideas in the market or in the real world, like the separate encryption projects or separate encryption and decryption applications, and people hide the image, people hide the data in the images as a separate application as well. And my goal is to combine everything into a one stop at one place and send my message. So I wanted to use different techniques to encrypt or to hide the data or the message that I wanted to send to point B. So here, this application is mainly uh, used in military applications, to be honest. And going forward, let us start the introduction from the beginning of what is the crossover and mutation. So in genetic algorithm, in the real time genetic information, so the genes, the parent genes will combine to generate a child gene. At the same time, here a new gene. So too many genes will be resulting into a new unique genes going forward. So the same concept has been applied in this cryptography, which is called the crossover, where the process of acquiring parent solution. So here I'm trying to generate a new encryption key out of the current message that we have generated to send to others. So at this point of at this step, I've introduced, I've utilized this crossover and mutation technique in order to get that new encryption key or the decryption key, which helps for us at the end, in the beginning to encrypt it and in the end to decrypt it. And mutation. So our encryption key or the decryption key that we are trying to generate using this concept with the help of DES algorithm as well. The mutation indicate in our concept, the mutation indicates the diversified, how diversified, how much uniquely that we can generate an encryption key, because it shouldn't get easily noticed or it shouldn't get easily guessed by the hackers or somebody, so that that is the reason why we want diversity in generation of that keys. So crossover gives us a new age keys, and mutation gives us let that key in a diversified manner, let that key in a unique way. So population generation is something like which comes from here. We can tell the population means like the encryption keys that we are trying to generate for every message that we are trying to send. So digital image watermarking. So digital image watermarking means it hides valuable data inside the picture. I mean, basically, there will be an image, and we can create a watermark using our message. So we can hide any message inside an image through a watermarking technique. So it is called the digital image watermarking technique. So an invisible signature embedded inside an image to show the authenticity or proof of ownership. Maybe uh, some of you all may have seen the watermarking that was there in a Word document or on an image like Pinterest, whatever. This image is copyrighted and owned by particular entity. Likewise, and contortion. Contortion is something like the regularly little and different perceptual models that we utilize to limit its perceivability. So, which means the regular images or the medical images or the military images, whatever, when we use them to hide some information or to change the course of that image, uh, is called contortion. And to be precise, in let's say in therapeutic imaging like X-rays and all, any change to the first picture may influence the doctor's finding in an X-ray, in a CT scan, or in anything in a brain in a brain X-ray image. If something is not normal, the doctor's findings and it will lead to the legal issues, like it will lead to the negative recommendations to the patient. Similarly, in military imaging, pictures are seen under non-standard subsequently, including a clamor, like a flag as a watermark, is unsuitable because they don't authorize, the military people don't authorize such kind of images in which there are flags. So in that capacity, this reversible watermarking, why we are implementing is to retract or to extract, to uh, keep the originality of the image by extracting whatever encryption message that we are hiding in that. So in order to take that out and keep the originality of the image, that reversible watermarking method is what we are using here. Continuing forward, the proposed approach in this concept is like fixed threshold based compounding. So here we are reducing the image, uh, to be precise, like compounding means if there is an audio signal or if there is an audio signal, the audio signal is compressed and we are sending it to a narrow pipeline, and then after going to the other side, we are extracting it. So this procedure is called compounding, and here we are using the fixed threshold based compounding in order to use the im- im- signal for the images while sending the messages from point A to point B, and followed by we'll be creating a threshold outline, and we will be creating a watermark creation there, and we will embed that watermark using this hidden data inside it, and then we will be extracting that watermark by decrypting this message what we have hidden there. So these are the series of approaches using this threshold based compounding. I would say fixed threshold based compounding is one of the key methods that I have used in coding in order to get the exact in order to not to miss the proper frequency of the imaging while sending it to the other side. So all this experimentation so far that I have explained, I have coded in MATLAB. using MATLAB coding. And using the MATLAB coding, I have also developed a GUI where it will be easy for us to explain and present the application of this project. So in this application, I have used the 2D images. So why the 2D images? There are the category of these 2D images are medical images, like the X-ray, CT scans, MRIs, and all that particular images. So why only 2D images? Because in digital image watermark, like the digital image watermarking hides necessary useful information in the image, mostly pertaining to the content creator or owner for content authentication, for copyright protection, etc., etc. The only limitation that it has is the original image is inevitably distorted due to the quantization, bit replacement, or truncation, because those things that are performing, those things that we are performing over there for that image. There's the reason that original image is distorted a little bit. That distortion might not be acceptable for certain applications which have sensitive imagery. So that's the reason image encryption step on image to transfer this sensitive or important image. Decryption and reversible watermarking. So once we did that, the image encryption and all that encryption methodologies has done, then we will be having a decryption key. By using that, we will be decrypting the image. We will be extracting the encrypted data outside, and then we will be decrypting the message itself. And then we will be able to see the original message which the other person is trying to send us. So after the experimentation, like the data set that I have used, or the images that I have used, or the compatibility of 512 and by 512 pixels. That is the only pixel images that I have used, 512 by 512. And the images that I have used are like X-ray, CT scan, ultrasound, MRIs, etc., which I mentioned earlier. These images are selected from the data to transmit the message that what we wanted to send. Altogether, like we have used everyone, we have used all the strategies into one stage with a proper GUI in which we can take the necessary steps to send a message with utmost security. For this, the proper explanation with the figure is there in the coming slides, and that image is like basic blend of four different types of images. So after performing these operations using this methodology, we can see the original image without distortion or without disturbance, without nuisance in the image. The watermarked images with textual data embedded in it, encrypted images, encrypted textual data in it together before that. The practical output for our approach can be seen in the following slides. So this is the MATLAB GUI that I've developed. This is the application, the user-facing UI, where a user can send a message and or see the message uh, by all the encryption and decryption will be happening from this phase. So this is the home page, and I've named it as reversible data encryption system. And it is in the encryption tab. When we click the encryption tab, we will see this screen. And on the left side, we will be selecting the input image that we wanted to use to send our message. And when we select this input image, we will be choosing any image like X-ray, CT scan, whatever, and it will be popped up here. And then we will be writing our text that we wanted, the message that we wanted to send to the other side. And here I have written new body image. And in the second uh, window that you're seeing here is the image that it has watermark. That means once after entering the message, we are encrypting the message. The encrypted message that you can see here. YQAJFNRAAHHH. This is the encrypted text of our actual message, new body image. And this encrypted text is embedded as a watermark inside this image. And that image with a watermarking of this encrypted text is visible in this second window. After that, we will be again encrypting the whole image that consists of the hidden data. And once we did that, the image will look like this. Because we have encrypted that, the image looks disturbed and distorted. And when we click the decryption, the opposite person will use the decryption tab and he'll click the decryption tab. Excuse me. The selected encrypted image. So the image that the other person sent us, we will be selecting, we will be uploading that image, and I mean, we will be inputting that image, and we will be selecting the encryption key that has generated with the by using the concepts of this crossover mutation and S encryption, etc. And then we'll hit the decrypt. In the first image is the encrypted image where the encrypted image that we have seen in the last slide is it's that encrypted image that we are loading here, and then we are hitting we are selecting the encryption key to decrypt it, and then the image was decrypted. And once the image has decrypted, by using the reversible watermarking technique, we are extracting the hidden message, the encrypted hidden message that was there inside the image. Okay, so after that, once the text was extracted, and we will be decrypting that text again, and we will be seeing the recovered text from that decrypted text. This is the encrypted text, and this is the decrypted text. So you will see the different decryption text here. I have used two different messages and used the screenshots. I have I'm presenting two different screenshots from two different examples. So that's why you will be seeing the other original text here, that my name is Khan here, like that. So overall, this is how the internal procedure, the backend works with the, I mean, even the user can see this with the help of the GUI. This is how it works with respect to my project. And the overall data and the overall images that I have used are these four different types of images that I have used. And if you see, the original 2D images can be seen in this left, the first section, processing image, ultrasound image, CT scan, and X-ray. And when we embed that image with watermarking, and that's how the image looks like in the second column. This is how the image looks like when we embed some message inside it using watermarking technique. And then overall, once we totally encrypt the image, including that, this is how the actual image, original 2D image looks like once we encrypt it. So these are the four different types of images that we have used to, I mean, also there are many other medical images that we have utilized in order to encrypt it and send messages. Uh, so the main drawback in this project or in this application, in this research was like, the research is still going on, and I'm still trying to upgrade um, the concept that we have implemented here. The main drawback here is this application will only process the alphabetical messages. Like it can't process the numerical data. So I have not coded the application accordingly to use the numerical data as well, because the alphabetical 64-bit processing messages we have used. And while I have implemented the numerical data as well, the numerical data lies between 0 to 9. And we have a number of possibilities that are coming up, and there is so much complexity that has generated. So I thought of taking that challenge as a next update for this application. So therefore, we cannot send the numerical data as of now with this approach, but it must be upgraded. Also, there is another drawback is this has developed in with the minimal computational power with a minimal uh, slow-paced and networking environments. But in the real time, in the military applications or in the government applications or whatever, we will be needing an excellent, greater computational power with a faster networking environment in order to process the messages, encrypt, decrypt, with the help of this core new methodologies that I've implemented in between an original message and a decrypted message. um, the future work with this application, what I wanted to take up forward is I'm trying to include the numerical data as well. Like we can the combination of numerical and alphabetical letters will be processed and will be used to send messages. And later we have we and later we also need to um, make the application compatible to the special characters as well, like dot, exclamatory, at the rates, and etc. That is one of the next step that we are working on right now. Also, um, this developed concept can be extended to merge into the AI, which is an advanced trial so that it can reduce the time complexity of the data transfer, also with the computational power as well. Like when I meant AI, it is related to the ChatGPT, OpenAI, and LLM large language model, NLP concept basically. So I'm also developing a new messaging application uh, which it's a regular messaging application which but in today's world we have WhatsApp, we have Instagram, we have Messenger and WeChat or whatnot. All these applications, like any industry or any messaging application is the only thing, the main thing that they compete for is how much secure their data is, how much secured their messages are going to the other person. Like whether if you send me a message to me, whether how much secured it is. I mean, whether there is any data leakage or whether there is any hacker who can hack it. That means the organization should provide that much security for the messages of their users. So I wanted to I wanted to use that gap and develop something to create a robust security between a point A to point B to send message so securely. So uh, this messaging application that I'm trying to build, I wanted to implement this concept. I want to add this concept and merge it into that application. And by developing an additional idea of generating into an LLM. So I will be joining an LLM model as well along with it. And I wanted to create a robust messaging application with a unique advantages. So this is my next steps. To conclude my topic today, overall, I have used crossover and mutation operators from the genetic algorithm into the encryption along with the DES algorithm to encrypt my message and to generate the encryption key, which is in a unique way. And the inserting and extraction procedures for this technique are successfully achieved with the help, with the goal of achieving alphabetical text. Excuse. And in the second phase, the reversible watermarking strategy has done the information covering up and image extraction, which is troublesome for a hacker to steal the data. We have achieved that using that reversible watermarking strategy. At long last, by the blending of both the techniques, we can effectively transmit the information with high security from point A to point B. I have utilized all these reference materials online, and thank you for so many authors and so many papers and journals down here for helping me into develop this concept and achieve the goal that I am looking to. And